Despite the lack of hops over recent months, SpaceX Starbase continues to be a hive of activity with preparations ongoing for both the upcoming orbital test flight of Booster 4 and Ship 20 and the future acceleration of launch cadence with follow-on vehicles. SpaceX rolled out its next version of Starship to the pad on August 5, 2021, as the company shoots for an ambitious orbital test. The Starship prototype, known as SN20, left its production facility near the South Texas village of Boca Chica to arrive at the launch pad, joining the Super Heavy first stage booster that arrived there 2 days before. While SpaceX and founder Elon Musk has yet to comment on the rollout on Twitter, the event was carried out live as the company prepares for this new mission, which SpaceX hopes to fly with the next few months, depending on technical and regulatory progress for the mission. The 230-foot tall, or 70 meters, Booster 4 will soon go through a series of pressurization and engine tests. Providing Booster 4 passes the trials, the rocket will then be prepared to send SN20 on a round-the-world trip. But it's unclear when the rocket will launch, given that the U.S., the Federal Aviation Administration, is performing an environmental review of Starship's launch operations, and there's no idea when that will finish. The recently published draft programmatic environmental assessment from the FAA, calling for public comment ahead of Booster 4 and Ship 20's flight, highlighted the requirements that need approval for the historic first push to orbit for the world's most powerful rocket. Due to the FAA requirement for an environmental assessment of the Starship's mission, SpaceX's plans to attempt the flight in July 2021 were delayed. Even after the assessment is finished, there could be more certifications to consider. Depending on the outcome of the environmental assessment, SpaceX may be also required to go through a more detailed review culminating in an updated environmental impact statement. Only after that process is complete can the Federal Aviation Administration move on to licensing a possible orbital Starship launch, CNN Business reported in June 2021. If all goes according to plan, the orbital flight plan calls for Booster 4 to splash down in the Gulf of Mexico, about 20 miles or 32 kilometers offshore, a few minutes after launch. SN20 will continue into orbit, making one circuit of Earth, and then come down in the Pacific Ocean roughly 90 minutes after liftoff near the Hawaiian island of Kauai. However, after weeks of mostly invisible, albeit slow and steady work at Starbase's suborbital launch and test facilities, SpaceX has finally kicked off the first orbital Starship prototype's first test campaign. Almost 2 months ago, Starship 20 S20 departed the factory. It was built in for the first time and was rolled a few miles down the South Texas Highway to Starbase's nascent orbital launch site. There, SpaceX briefly installed Ship 20 on top of a Super Heavy Booster 4 B4, an important first and one done with the same ship and booster pair CEO Elon Musk says could eventually support the rocket's inaugural orbital launch attempt. Mere hours after the August 6 photo opportunity and fit test, Ship 20 was rolled back to the Starbase build site for another week of work before returning to the launch site. This time around, Starship S20 headed for one of the 2 suborbital launch and test stands and ultimately spent the better part of the next 6 weeks sitting in place as workers swarmed around the 50-meter or 165-foot tall spacecraft and upper stage to prepare for the next steps. In theory, those steps were simple enough, beginning with the completion of 2 basic qualification tests, the same test that half-dozen prototypes preceding Ship 20 completed without issue. Effectively, SpaceX's first Starship or Super Heavy test of any kind in more than 2 months, and it thankfully didn't take long for things to get interesting. Ship 20 was initially filled with gaseous nitrogen, now called the pneumatic test, and formerly known as the ambient test, before being loaded with super cold liquid nitrogen LN2 for the cryogenic test. Before the pad had even been cleared of the last few remaining workers, Starship S20 violently shed a good dozen or so fragile heat shield tiles. CEO Elon Musk quickly confirmed speculation that Starship S20 had effectively jetted the tiles off its nose during a brief test of high-pressure cold gas maneuvering thrusters, coincidentally around the same time as SpaceX began to pressurize the rocket for its first tests. Musk says that one of those thrusters blew away some of the adjacent heat shield tiles. Going into what was believed to be Starship S20's first ambient temperature pressure test and cryogenic proof test, the loss of some heat shield tiles was almost universally expected. In a structure as large as Starship, even just the thermal contraction of steel at supercool temperatures and expansion as it warms back up could change the rocket's diameter an inch or so, potentially causing tiles to scrape or press against one another. About the size of a dinner plate and the thickness of an average paperback book, Starship's ceramic heat shield tiles have proven to be very fragile, with dozens routinely chipping, cracking, and shattering during and after installation on Ship 20. One unique aspect of Starship and SpaceX's decision to mount its heat shield directly to the thin steel propellant tanks and skin that make up the rocket's entire airframe. SpaceX's first stab at the problem involves studs pins welded by robots directly to the exterior of the Starship's tanks and skin. By embedding small metal plates inside each cast tile, they can be easily installed by aligning the tile and pressing it against each set of 3 barb-like pins, which then irreversibly lock in place. Over most of Starship's hull, SpaceX then tacks on blankets of off-the-shelf ceramic wool insulation before tiles are installed on top of the steel and blanket sandwich. Compared to the Space Shuttle and Russia's Buran, the only other orbital spacecraft to fly with non-ablative heat shields, Starship's Thermal Protection System, TPS, is incredibly simple. Of course, the challenges imposed on heat shields by mechanical stresses during launch and landing, orbital re-entry, and need for rapid reusability are anything but simple. As such, to see tiles blown off of Starship S-20 by cold gas maneuvering thrusters that were simply placed too close to adjacent TPS was an unexpected route to an expected outcome. During one of the recent Monday's 9-hour test window, SpaceX appeared to be partially or fully pressurized Starship S-20 at ambient temperatures before aborting a cryogenic proof test either before or just after it began. While an ambient temperature proof was easier of the two tests on the rocket, it's still encouraging to see no obvious tile loss caused by the actual mechanical stresses involved in the test. Most importantly, compared to losing dozens of tiles to regular mechanical or thermal stresses, fixing an issue with thruster infringement is much easier and should only require a few design tweaks to one specific Starship component. The real nail-biting moments will come during Starship S-20's seemingly imminent cryogenic proof and static fire debuts, major TPS issues during either of which could necessitate vehicle-wide design changes and cause delays. Other objectives of the proof test include using thrust rams, which are hydraulic rods, to simulate loads on the thrust pack. A clue to the next phase of testing will be noted once this device is removed, allowing Ship S-20 to prepare for static fire testing. Loaded with liquid nitrogen LOX and liquid methane CH4, it is expected that Ship 20 will initially fire up its 3 sea-level Raptors, followed by unspecified testing with the 3 RVACs. However, only one RVAC has ever been fired at any one time, with all the testing conducted at SpaceX's McGregor site as opposed to Starbase. While Ship 20 moves through its test objectives at the suborbital pad, Booster 4, next door at the orbital launch site OLS, will follow a similar path with proof testing objectives before what is likely to be a series of static fire tests. Interestingly, Booster 4's test will be aided by the use of OLS Tank Farm, which has been building up its set of commodity tanks over the last few months. The final version of the Starship spacecraft will have 6 Raptor engines, and the final Super Heavy version will likely be powered by 32 Raptor engines, Musk has said. The upper stage is 165 feet or 50 meters tall and is also known confusingly as Starship. With any luck, whatever forced SpaceX to abort Starship S-20's first cryogenic proof test can be easily rectified, opening the door for additional attempts. Would it be a success? Tell us your thoughts by leaving a comment in the section below about the Starship SN-20.